Now, all of the examples that we just saw used a triangle or a trapezium or a circle, something that we knew how to find the area of. If we've got to deal with something that's a little bit more tricky, then we're going to learn later how to find the exact area. But for now, let's just look at a method that we could use to estimate the area. And we're going to use rectangles again, but two sets of rectangles, upper and lower ones. Now, let's just start by thinking about what our question's asking here. We want to find the area between x equals 0, x equals 4, and this function, y equals 25 minus x squared, and the x-axis. So let's draw this up so we can have a look at what we're dealing with. Now, if I think what y equals 25 minus x squared looks like, you might prefer to think of it as y equals minus x squared plus 25. We know that that's an upside down parabola that's been lifted up 25 units. So if I let it come up here to 25 and come down something like this, that's something of what we're looking at here. Now, we want to find the area between the line x equals 0, which is just the y-axis, and x equals 4. So let's think, what's this point out here? Well, I can easily factorize this and say that's the difference of two squares. Always be on the lookout for that. So if I let y equal 0 to find the x-intercepts, obviously x needs to be 5 or minus 5. Now I've got a better picture to work with. All right, we're just looking for the area though between x equals 0 and x equals 4. So I need to come back from 5 to 4. Now this is the area in here that I'm looking for. That doesn't look quite straight, does it? You get the idea. All right, so how am I going to do this with sets of rectangles? Well, I can take this point on the curve and work out what it is, can't I? If x equals 4, what would y be? Well, just go ahead and sub it in. 25 minus 4 squared, that's 25 minus 16, that'll give me 9. Obviously, I'm not very well to scale here, but that's okay. So I've got a rectangle like that. All right, that's a lower rectangle. Can I make an upper rectangle? Yes, I can use my other known point here and make a rectangle like that. So they're sitting right on top of each other. Now, can you see that if I find the area of this entire blue rectangle, it will be 4 times 25, base times height. That's 100. So using one set of rectangles, I could say, well, it's somewhere between 100, but that's a little bit too big because I actually just want the area under the curve, don't I? I don't want that whole bit on top there, so 100 is going to be too big. Or I could use another estimate and say, well, it's going to be sort of maybe a little bit bigger than this lower rectangle. Well, the lower one's way too small, actually. 4 9s are 36. So using one set of rectangles, I'd say that my area, which I'm still going to call exactly the same as my question, 25 minus x squared dx, that area is somewhere between 4 25s, which is 100, and 4 9s, which is 36. So I've kind of narrowed it down, haven't I? I've said it's somewhere between 36 and 100. Well, that's not a great estimate, is it? I think we can really do a lot better than that. We're going to have another couple of goes here using 2 sets of rectangles and then 4 sets of rectangles. Okay, so to draw 2 sets of rectangles, to me it makes sense just to halve the space that I've got between 0 and 4. So I'm going to make a vertical line at x equals 2, and then I'm going to build my rectangles. So firstly, it's good to know this point here. We already saw that 4 lines up with 9. And if I sub x equals 2 in here, I've got 25 minus 2 squared, and that gives me 21. Okay, now I need to just make sure we've actually got 2 sets of rectangles, some that go above the curve and some that go below. So I'm going to go ahead and draw another box up here and another one out wider. Now you can see that the area that we're actually looking for is this part that I'm going to shade blue, but we can estimate it now by saying it lies somewhere in between this rectangle plus this one, which is going to be a little bit too small of an estimate, isn't it? Or it will lie between there and this rectangle plus this one, which will be a little bit big. Hopefully we'll have a better estimate than this one, which was pretty shonky. All right, so let's start by, oops, this needs to be a 4 here. Let's start by writing in an expression for our area and say it's between this and that, and we can figure the two out. All right, the estimate that's too big, let's do that first. We've got a rectangle that's 2 wide and 25 tall. So 2 times 25 is 50, and then we need to add it to 2 times 21. So we've got 50 plus 42, 92. It's a little bit smaller than our previous estimate. And the estimate that's a little bit small, we can see it's going to be too small, but we'll figure it out anyway. It will be this rectangle, which is 2 times 21, plus this rectangle, which is 2 times only 9. So we've got 42 plus 18, we've got 60. Okay, we're still not too sure exactly how big our area is, but we've narrowed it down a little bit. It's something between 60 and 92. So this is clearly a better estimate than the last one. Let's go ahead and break our area up into 4 sets of rectangles now. Okay, so we've already seen that when x is 4, y is 9. When x is 2, y is 21. But when x is 1, y will be 24. And when x is 3, y will be 25 minus 9, which will give us 16. Now we can go ahead and build our upper little set of rectangles by making boxes that sit above the function. Now this should give us a better estimate. We'll go ahead and set up our working here. We're looking for the area between our function and these boundaries and the x-axis, and we're estimating it's between something and something. All right, let's do the small set of rectangles first this time. So each rectangle is only 1 wide, so the base is 1. So we really just need to know how tall it is, and that will give us the area. All right, well, the small rectangles are these ones. They come stepping down like this. So we have one that's 24, we have one that's 21, and we have a 16, and we have a 9, and we really just need to add those together. So we're going to get, what's that, 70. That's getting closer. And then if we go ahead and look at the large set of rectangles, well, this one is tall, it's 25. And then we have the 24, the 21, and the 16. So those are the numbers that we'll need to add together. And you can see here that we're going to get an upper boundary of 86. So we haven't yet worked out exactly how big this area is underneath the curve and between these boundaries, but we're narrowing in on it and we're getting closer and closer. And once we get to the point where we're going to actually just integrate our curve using integration, we'll be able to jump to a number that's the exact number of units squared.